Hi guys, during previous weeks when we've looked at multiplication and division problems, we've focused on analysing those problems in order to help us make decisions about the strategy that we're going to use. This week we're going to focus on developing success criteria for a particular strategy. We're going to be looking at partitioning arrays. To begin with, let's get thinking. Here we've got an array with 3 rows and 4 counters in each row. So this array represents the multiplication story 3 times 4. I know some of you might just know the answer to that, but what I'm interested in is, if I don't know 3 times 4, what else might help me? So pause the video for a few minutes, discuss that with a partner, and then share your ideas with the class. If I'm not sure what 3 times 4 is, I can split that array up into parts in order to help me. So rather than trying to work out 3 times 4 all at once, I might split that into 2 rows of 4 and 1 row of 4. 2 times 4 is 8, 1 times 4 is 4, so all we need to do now is add them together to get the whole amount. 8 add 4 is 12, so therefore 3 times 4 must be 12. We could have partitioned that a different way. Let's split that array into 3 rows of 2 blue counters and 3 rows of 2 red counters. 3 times 2 is 6 for the blue counters and again for the red counters, so all we need to do is add the 6 and the 6 to get 12 again. Or we might have split that array into 3 rows of 3 blue counters and 3 rows of 1 red counter. 3 times 3 is 9, 3 times 1 is 3, and once again we're just adding up those parts in order to get the whole amount of 12. Here we've got our array of 3 rows of 4 which makes 12, or we can say 3 times 4 equals 12. Now we don't need to memorise all of the times tables facts if we can make connections between those facts. So now what I'd like you to think about is, if we know 3 times 4 equals 12, what else can we work out? Pause the video for a few minutes and discuss with a partner what other times tables facts can we work out just from knowing that one fact. Let's have a think about what other facts we can work out just from knowing that 3 times 4 equals 12. Well, to begin with, we might add another row. So rather than having 3 rows of 4, we've got 4 rows of 4. I've added another row of 4, so I'm just adding 4 to the 12 to get 16. So 4 times 4 is 16. What about if we take one of those rows away? Instead of having 3 rows of 4, we've got 2 rows of 4. We've just taken 4 away from the 12, so we get 8. So 2 times 4 equals 8. What about if we double those rows? So rather than having 3 rows of 4, we've got 6 rows of 4. So I'm just doubling the 12. And double 12 is 24. So I can work out that 6 times 4 is 24. What if we add another 1 to each of those rows? So rather than having 3 rows of 4, we've got 3 rows of 5. We've added an extra 1 to each row. We've added another 3. So 3 times 5 is 12 plus an extra 3, which is 15. We can also use this array to work out some division facts. If we've got 12 altogether and we split them into 3 rows, then there are 4 in each row. So we can say that 12 divided by 3 is 4. But we can also split that 12 into 4 parts. We've got 3 in each part, so we can say that 12 divided by 4 equals 3. Rather than each of those counters being worth 1, they might be worth 10. So rather than having 3 rows of 4, we've actually got 3 rows of 40. And I can see there, 3 lots of 40 is 120. So 3 times 40 is 120. What we can also do with that array is we can turn it round. So rather than having 3 rows of 4, we've now got 4 rows of 3. We didn't take any counters away, we didn't add any counters, so 3 times 4 is the same as 4 times 3. So 4 times 3 is also 12. Now that's called the commutative law, and that's really going to help us with our times tables. If I understand that I can make an array to represent any multiplication, and I can turn that round, that means, for example, if we know that 3 times 8 is equal to 24, then I also know that 8 times 3 is 24. What about 3 times 24? If I tell you that 3 times 24 is 72, then we can also work out that 24 times 3 is also 72. So if you've seen a multiplication grid like this and you think that's a lot of facts I need to remember, just from knowing the commutative law on its own, that means that we can take out almost half of those facts. If I know 3 times 7 is 21, I know 7 times 3 is 21. If I know 9 times 8 is 72, I know 8 times 9 is 72. It's time to get investigating with a partner. Bart has made an array with 4 rows of 5 using 20 figures. So there you can see his array. Now we know that 4 rows of 5 gives us 20 figures altogether, so we can write a multiplication story. 4 times 5 equals 20. He wants to split the array into 2 parts using blue and red figures. Can you find different ways of splitting the array? Now Bart's going to use a line in order to do this, and he can either use that line vertically, so up and down like you can see there, or he's going to use it horizontally, so across like you can see here. So to begin with, he might put that line there, which means he's going to change those blue figures into red figures. You can see here he's got 3 rows of 5 blue figures, which gives him 15 blue figures altogether, so we can say that 3 times 5 equals 15. He's also got 1 row of 5 red figures, which gives us 5 red figures. So we can say 1 times 5 equals 5. And we can use a number line to record how we work this out. We've got 15 blue figures and we're adding 5 red figures to give us our 20. Can you find other ways that Bart could split that array into 2 parts? Pause the video for 8 to 10 minutes. Use double-sided counters if you've got them to make those arrays. You can draw those arrays and write a description of them and then write the multiplication story. You might even want to use a number line to show how you would add the parts at the end. Let's discuss how Bart might have split those figures up. Now there are lots of different ways to do this. I'm going to show you just some of the ways he might have done that. To begin with, he might have split that array like you can see here. He's changed those blue figures into red figures, so he's got 2 rows of blue figures, which gives him 2 times 5, which gives us 10, and 2 rows of red figures. Once again, we've got 2 times 5, which gives us 10, so we're adding another 10 to get to our 20. He might have split this array like so. We've got 1 row of 5 blue figures, and 1 times 5 is 5. We've got 3 rows of 5 red figures, and 3 times 5 is 15. So we're starting with our 5, we're adding 15 to get to 20 again. Or he might have split the array vertically. Here you can see we've got 4 rows of 4 blue figures, and 4 times 4 is 16. We've got 4 rows of 1 red figure, and 4 times 1 is 4. So when we add that onto the 16, we get our 20 again. And the last one I'm going to show you is by splitting that array like so. We've got 4 rows of 3 blue figures, which gives us 4 times 3, which we know is 12. We've got 4 rows of 2 red figures, and 4 times 2 is 8. So we're adding 8 to the 12 to give us our 20 again. So if we don't know 4 times 5, there are lots of ways of splitting that up in order to make it easier for ourselves. Now you might already know 4 times 5 is 20, so you don't need to split that up. But by being able to split up a multiplication story in parts like this is really going to help us with bigger multiplications that we might find tricky. It's time to discuss our success criteria. How did we achieve success? So pause the video for a few minutes and discuss with a partner the steps that you would have to go through in order to solve similar problems. So how could we work out any multiplication story that we don't know? Let's use 4 by 5 to demonstrate this. The first thing that we can do is we can draw or build the array. So here you can see we've used counters to draw an array that has 4 rows with 5 counters in each row. If we're not sure how to multiply 4 by 5, then we can partition that array. We can split that into parts. So let's split that 4 times 5 into 3 lots of 5 and 1 lot of 5. Once we've done that, we can calculate the value of each part. 3 times 5 is 15, 1 times 5 is 5, and the last thing we need to do is add those parts together. And 15 plus 5 gives us 20. So 4 times 5 is 20. To begin with, we're using those arrays to help us, we're building those arrays because that's going to help us visualize. So when I'm trying to work out a really big multiplication in my head, I can use that strategy in order to break that into parts that I can add together more easily. It's time to try that out, and this week our challenge looks a little bit different. You can see here we've got 3 different arrays. We've got a yellow array that's made of 3 rows of 6 counters, we've got a green array that's made of 5 rows of 7 counters, and we've got a red array that's made of 7 rows of 8 counters. And what I'd like you to do is, can you find different ways of partitioning just one of those arrays? So choose either the yellow, the green or the red and see how many different ways you can partition it. For the green and the red, there are lots of different ways. You're not going to get all of those ways done in the time. So rather than trying to find all the different ways of splitting it, you might think about what are the ways that I could split that to make it easiest for me to work out. So draw the array, partition it into 2 parts just like we did before, describe the parts and show the multiplication stories. If you manage that in the time, then this week I want you to choose a multiplication fact that you find particularly tricky and show how you could partition it to make it easier to work out. Pause the video for 10 minutes or so, use resources to make those arrays, ideally double-sided counters so that you can flip them over and split them into 2 parts. Draw the array, describe it, write the multiplication fact, and you might even want to use a number line again to show how you're adding up the parts. It's time to reflect in today's learning. So with a partner or as a class, I want you to think about the following questions. What have you learned today? What did you find easy or difficult? Did you get stuck? What helped when something got tricky? What do you need more help with? What is really making you think? And what are your next steps? The last thing I'm going to ask you to do today is, can you apply what we've learned? So as a class, I want you to discuss, analyse and solve the following problem. The 6 ninjas go to a concert together. A ticket costs £16. How much do they pay altogether? And what's the easiest way to work that out? Thanks for joining me again today. I hope you enjoyed that. As ever, if you've got any questions or you'd like to share your solutions with me, you can contact me at scott.morrow@southayrshire.gov.uk or you can tweet me at scottmorrowsa. Next week, we're going to be analysing solving problems that involve mixed operations. I hope you can join me then.